Okay, so the next topic on our agenda for today is the idea of a greatest common factor. Okay, so you've actually already looked at this in middle school with numbers, but obviously now we're going to look at it with polynomials, or in this case monomials. Okay, so the question you're asking yourself when you're looking for the greatest common factor is this. Okay. What is the largest value, usually a number, I can divide each term by? Okay, and when we do that, we actually still want to have an integer or a polynomial. We don't want to, we can divide obviously 30 by any number we want, but we only want to talk about whole numbers. So if I look at 15 and 20, and I'm looking for the greatest common factor, well, I know that the factors of 15 are, let's see, I can divide 15 by 1, by 3, by 5, and by 15. Okay? 20 has some more factors. I can divide it by 1, 2, 4, 5. Let's see, what else? I can't do 8. I can do 10, and I can do 20. Okay? So when I'm talking about the greatest common factor, right, GCF, I am going to be looking at the largest number that's in both lists, right? So we've done this before. You've done it before in your math careers. With these integers, the greatest common factor is 5. All right, now let's talk about a monomial. All right. So now, instead of having numbers like 15 and 20, we have monomials, like 4x to the third and 12x. Okay. It may help to think about what this is. So this is 4 times x times x times x, and this is 12 times x. Okay. So immediately, when we're talking about GCF, okay, I'm seeing an x that they both have. Okay, so they both just have one x, but an x is going to be part of the greatest common factor. Okay. Now we have to look at our numbers, right? Because we can't take any more x's out. This one has x and x, and this one doesn't have any x's left. So now I want to look at 4 and 12. Okay. The greatest common factor of 4 and 12. Go ahead and think for about 10 seconds about what the greatest common factor of 4 and 12 is. Okay, so the greatest common factor of 4 and 12, let's write them down. 4, my factors are pretty easy. They're just 1, 2, and 4. Okay. 12 gives me 1, 2, 3, 4, 6, and 12. Okay. So my greatest common factor of those two numbers is 4. So the greatest common factor is 4x. Okay. Now let's look at a slightly trickier example. I'm actually going to change it slightly. I'm going to change it to 7x to the third and 10x squared. Okay. So I think it's probably helpful to write this out first. So 7x to the third means 7 times x times x times x. And 10x squared means 10 times x times x. Now, eventually, you'll get to a point where you're not writing them out every time, okay? But that you can always go back to that if you're stuck. So let's look at the x's first. I see that they each have 2 x's to give, right? So that means part of my GCF is going to be x times x, which is x squared. Okay. Now let's think about 7 and 10. This is a little tricky, right? They don't have any common factors except for 1, right? Because 7, the factors of 7 are just 7 and 1. 10 is 1, 2, 5, and 10. So the greatest common factor here is just going to be, sure, I could write a 1x squared, but it's really just x squared, All right. So in this set, what you're going to do is you're going to go ahead and find the GCF of the monomials that are given to you. Go ahead and start that now.